Good afternoon, guys. This is going to be a tutorial on using Cameo Systems Modeler to open a 3D image file. So what you may have begun with would be a model such as this, where you have a block that could represent a part of a system or an entire system. In this case, it will be a spacesuit. And then what you can do is use simulation to launch that 3D image file and open that in a web browser. And what that uses is the Windows command line tool that Cameo has built into it. So we'll run a simulation and then you will see exactly how that happens on the back end. So I'm going to run a simulation of that block itself. It'll go and execute this behavior, and then it opens the file, and then you can manipulate that, zoom in and out on it, different things like that you may want to do while viewing a 3D image. So how would you do something like this? Well, this is a .glb file, and in order to view a .glb file, you'll need to have a Python server that is hosting that, then leads the Python server to where your index.html file is living, and inside of that index.html file, you have a pointer to that actual .glb file. So let's take a look at how to put some of these ideas together and then launch that through a simulation in Cameo. So if we jump into this behavior I've named View 3D Image, what you'll see is I've taken advantage of the built-in Windows command line behavior that comes with the simulation profile. So if you notice, this is a simulation profile that is in the auxiliary resources. If it's not there, you may have to load that. And then down in the library package, you'll also notice you have this Windows command line behavior that you can then feed text into, and that's what I've done here. If you've never used a value specification action to do that, if you look in the drop-down menu for your actions, you go to any action and then value specification action. That's how you can enter in a string of text, and this string of text is essentially a batch file that will then execute in the command line to start up the Python server and then lead it to where you have that file stored. So let's look at some of these scripts that are used to do this in the background. I've created a folder or directory named Model Viewer 3D that has a CSS directory, and in the CSS directory there is a style.css, which is typical for any web app you may have where it has some styling and fonts listed. So if we look at that, it is very simple. It has a few things in there about the width, and that's about all you need there. I got all of this scripting from ChatGPT. So if you needed to have any code like this, you can simply ask ChatGPT to create it for you, and that's what I ended up with here. So notice I also have a directory or folder named models, and in that I have the .glb file. That is the 3D image itself, and it's named model.glb, which then gets called out in this index.html file and referenced as well. So if you notice in Cameo, it opens the index.html file. What you'll see is in the index.html file, it has a section here that points it to that model.glb. If you put all of that together, you would then access that through the web browser. So you do also have to have Python involved. And as I mentioned, that is necessary because if you were to try to execute this without that Python server hosting this, it won't actually be able to navigate to that part of your directory due to security restrictions on web browsers not being able to access all of the folders or directories on your computer or whatever system you're working with. That's why that Python server is necessary. So that opens up very nicely, and it would be a great way if you're trying to show people different things in your model. You could have different behaviors involved. You could improve this quite a bit by parameterizing this behavior, where maybe you would feed it a different file path that would go to some other image. So there's a lot of ways you could improve upon this. I thought it was neat to be able to run that from a simulation, have that go directly to a 3D image. And I want to give a huge shout out to Jacob Linville, who told me about this approach and gave me a few pointers for how to execute something like this. So Jacob, thank you very much. If you guys have any questions on this, please feel free to reach out.